Hi, welcome to this session. In this session, we would be discussing about how would you like to see your data, the makeup of your data. So we would be using the descriptive statistics or the summary statistics to understand the makeup or the distribution of your data, right? So the first and foremost step, I'll import the data, and we have learned this several times how to import the data. So if you haven't seen that, or if you are not aware that, you can just click on that I button on top and you could see the previous videos in which I have discussed how to import your data when your data is in different formats. So right now I'm using a CSV format. So the function that I'm using is read.csv, file.choose, and header equals true. Okay, so for complete description of this function and how to import, as I told you, you can refer to my previous video. So right now my data is named as my data. So to give you a basic understanding of the data that we are trying to use, I'll just show you what my data is all about, so you get a fair idea of what my data is. So here, this is the data. So this data is about few students, okay, and that would be around 200 students, and these are the ID numbers of the students. So this is the nominal data. It doesn't have any impact on your analysis. And then the second column talks about the number of awards received by various students. The third column talks about the program they are enrolled in. So the programs over here are program 1, program 2, program 3, and so on. Okay. And then the fourth column talks about the score they have attained in the subject of math. Right. So this is the data, and I would like to see the makeup of my data, the distribution of my data. Okay. So how do we do it, and how we go ahead with that, how we proceed with that? So that is the agenda of this entire session. So moving back to my RStudio, first and foremost, we would learn to get the summary statistics, or what we call them as descriptive statistics. Okay, so here I'm not using my entire data to do this analysis. So let us first subset the data. Here my objective is I wish to compare the math score for the students enrolled in program 1 and the students enrolled in program 2. Okay, so this is the basic idea. I need to make a comparison between the math score of students enrolled in program 1 vis-a-vis those students who are enrolled in program 2 and what their math score was. So the first step, what I'm doing is I'm subsetting my data. So in the previous sessions, we have learned how to subset the data as well. And if you haven't seen, or if you are not aware of how to subset your data, I will just put the link on top. You can just go ahead and you can watch them. Okay. So I'm just making a subset of, first subset is, I'm just making a small data table of math scores of students in program 1. Okay. So here the my data consists of all the entries, around 200 entries, and in which I'm mapping all those students who are enrolled in program 1. Okay. The logic over here is I want to extract, or I want to pull out those students who are enrolled in program 1. That is to say, those rows which have got program 1, okay, in the program column. So these are those rows, and I'm selecting only column number 3 and column number 4. I'm ignoring the column number 1, which consists of the IDs of the students. I'm ignoring column number 2, which consists of the awards received by the students. Okay, so I'm just focusing on one column which consists of the program, the second column which consists of the students and their marks in math. Okay, so when I run this, I would just show you how my P1 or program 1, the data looks like. So just let me show you that. So PR 1. So when I look at this, this is how my data looks. So under program column, all the programs are 1, and in the math column, you see the scores obtained by those students. Fine. So I just close it down. The same thing I'm doing about program 2. I'm creating a subset for program 2, right? So this is my data, which consists of the entire data. And then in the rows, I want to choose only those rows which contain 2 in the program column. And I'm picking only column number 3 and column number 4. That means I'm ignoring column number 1 and column number 2. Fine. So this is PR2. Now, let us understand the first thing, okay? I'm trying to get the, let us say, summary statistics. So let's find the summary statistics. Okay, so here, summary statistics of program 1. Just the basic function summary, and I'm taking the column, only math column, from the data table or data set PR1. So I'm trying to get the summary or descriptive stats. So let's see, this is the summary statistics. All the summary statistics are saved in sum P1, and same way I would save all the summary statistics from sum P2. Okay, so sum P2 consists of all the summary statistics of students enrolled in program 2 and their math scores. Okay, so let's see what the summary statistics tell me for program 1. So you could see these are the summary statistics that I've obtained. Okay, the minimum score obtained by any student in program 1 for math subject is 35, whereas the maximum obtained by any student enrolled in program 1 in the subject of math is 63. The mean score is 50.02. The median is 49. Okay, and you have your first and the third quartile, 43 and 57. We'll discuss what are quartiles in the forthcoming part of this same session. Likewise, if I wish to see the summary stats of students enrolled in program 2, then just run this and you get to see this. Now, when you just compare, you see that the mean score is quite different, right? 50 is for program 1 and 56 is for program 2. Likewise, the maximum 63, 75, 35 and 38 is the minimum. So it appears that students in program 2 are performing better in math when it comes to program 1, right? So let us see. This is what the basic summary statistics. But is this enough to understand the distribution of my data? So a similar thing, just like finding the summary statistics, you have another function called 5num summary. It gives you the summary statistics in 5 numbers. Okay, so here everything is provided to you, like the minimum, maximum, first quartile, second quartile, and median. Mean is not provided. So let us run this. It gives you, it's almost, I would say, it's a duplication to summary. But anyway, we have this function. So I just wanted to inform you that you have this function. Okay, so if you just see what exactly you get from here, you see this is the 5num summary. Okay, 35, 43, 49, 57 and 63. So 35 is the minimum, 63 is the maximum, 43 is the first quartile, 57 is the second quartile, third quartile, and 49 is the median. Likewise, if you just wish to compare it with program 2, you would see this is the 5-number summary for program 2. 38, 50, 57, 63 and 75. 38 being the minimum, 75 being the maximum. 57 over here is the median, 50 is the first quartile, and 63 is the third quartile. Right? So that is the basic essence of your summary statistics. Now, why do I need to know the summary statistics? it's important for me to know the summary statistics to get a fair idea what my data is, how it's distributed, what are the central tendency values. The mean and the median gives you the central tendency values, whereas the maximum and minimum gives you the spread. What is the range, right? So I get that I become a bit familiar with my data once I know the summary statistics. Further, if I just need to know the mean, okay, only the mean. So you have this inbuilt function like mean. It's absolutely the similar thing as average in your Excel. So I would like to just demonstrate how do you find mean. So for program 1, I calculate the mean. The function I use over here is mean. For program 1, I select the math column and I get the mean for program 1. I run the second line, I get the mean for program 2. So let us just make a comparison and see. Run this part, this is 50.02. Likewise, I run this, I get 56.73. So these are the various means. Now I get to know the mean. I get to see that, okay, in program 2, the students have performed, the average performance of the students is better in the subject of math. Now I wish to see how far the scores of students lie away from the mean. That is to say, how much of variation exists within my data for program 1 as well as program 2. In such case, you need to use a measure or a metric. I would call it as standard deviation. Okay, now let us do it. I'm calculating the standard deviation for program 1 and standard deviation of the math scores for program 2. The function that I use is SD. Okay, SD, standard deviation, as simple. So just run it. Now I get the standard deviations for program 1 as well as program 2. Let's just see the values and make a comparison. Now I see that the standard deviation for program 1 is 7.4. whereas the standard deviation for program 2 is 8.7. So now these parameters that I see for standard deviation in program 1 is 7, whereas that of program 2 is 8. That means the variation in program 2 is much higher compared to that in program 1. The other interpretation could be that the distribution of marks in program 1 is more symmetric compared to that of program 2. And when I say it is more symmetric, you can get a visual appeal of the same or a visual understanding of the same when you build a histogram. So the next thing that we are going to do is to build a histogram and see visually what I mean to say that the marks or the score in program 1 are more symmetric compared to that of program 2. Let us see. Now I'm building a histogram for the marks in math for program 1. The function we simply use is hist and use the column. So histogram, as I mentioned earlier as well, it is a univariate visualization. That is to say, it requires only one variable. So let us run this. So you could see this is the histogram for program 1. So here you can see that the distribution is quite symmetric. Okay, that is to say you can't see much deviation or much variation over here. Reasonably symmetric. But if you compare it with program 2, let us see how it performs for program 2. Now this is, I'm building a histogram for program 2. Let us run it and see. Now this is the histogram for program 2. Now you can see this is so small. Okay, that is to see the frequency. That is, I would say that the number or the frequency of people scoring somewhere less than 40 is around 1. Okay, and the length or the height of these bars are talking about how many students are scoring in that range. Okay, and on the x-axis you get the bins. So this kind of, you can see the low values were not prevalent when we were visualizing the math scores for program 1. So basically, or ideally, that is what I meant by the histogram for program 1 would be more symmetric compared to that of program 2. We can get better idea by moving further and understanding things better. Okay, now let us see. The next thing that we will understand is quantiles. Okay, here quantiles means what we are trying to do is we are creating equal sized bins or buckets, and we are trying to see how much of your data lies within those bins. Okay, so let us see in program 1. Let me find the quantile. The function used over here is quantile. Okay, so for program 1, let us calculate the quantiles. For program 2, these are the quantiles. Now let's make a comparison. The quantiles for program 1, you could see that 0, 25, 50, 75, 100. Okay, so for 0% I have 35, for 25% I have 43. This simply means, like when I say for 25%, it is 43. That is to say that 25% of your data lies below the value 43. Okay, and there is 0% of the data which lies below 35. Almost there is 50% of your data, or 50% of your students are scoring less than 49, whereas 50% of students are scoring more than 49. Okay, likewise when it comes to 75%, you have 57. So it simply means that there are 75% of the students scoring less than 57, and there are 25% of the students scoring more than 57. And there are 100% of the students who are scoring less than 63. So this is the interpretation of that. Okay, so let us understand or see what is happening in program 2. So if we just try to see the comparison in program 2, you could see the same. Okay, as I told you. Okay, so for 0%, or 0% of your data, or 0% of your students are scoring less than 38. That means everyone is scoring greater than 38. And 25% of your students are scoring less than 50, and so on. Now you could understand what does this quantile signify. Now, if I want to understand the same thing visually, you have a beautiful visualization called box plots. Okay, technically they are called box and whisker plots, but generally we use the term box plots. And let us construct the box plots for program 1 and program 2. Now, the function is quite intuitive and simple. The function is simply box plot. So box plot for program 1. So this is the box plot for program 1. Over here, the thick line that you see over here is called the median. Okay, and the upper line for this box is the third quartile. And the second line over here that you see, this is the first quartile, that is 25th percentile. Okay, the top one is 75th, this is the 50th. This is the minimum and this is the maximum value. Right? That makes sense. Now let's see the box plot for program 2. So when we build the box plot for program 2, you see this is the median, this is the quartile, third quartile, this is the first quartile, this is the maximum, this is the minimum. So when I'm making two different box plots, it becomes difficult for me to make a comparison. So let's try to compare the both box plots by putting them side by side. So the function is the same box plot. This is the box plot for program 1. This is the box plot for program 2. Put together, you get a combined box plot. So this is the box plot for program 1. This is the box plot for program 2. Now you can see that the minimum score of students in program 2 is better than that of students in program 1. Likewise, the median score in program 2 is almost equivalent to that of students near the 75th percentile in program 1. Okay, that is to say, almost 50% of the students, 50% of the students in program 2 are scoring as much as what 75% of the students are scoring in program 1. And the same way you can see the maximum marks in program 2 is much higher than the maximum marks in program 1. So through this visualization, it becomes very easy for you to make the comparison. Okay, but many a times what happens is, box plot being technical, it becomes difficult to understand by laymen. Whereas a histogram is more intuitive and you do not require much technical knowledge to understand exactly what's happening. Okay, so you can use box plots when you are making presentations to people who have that technical awareness, whereas histograms can be used to express or show any data or any interpretation when you do not when you have an audience who are not very well acquainted with technical understanding or technical knowledge, right? So I hope you enjoyed this session and found this useful. Do spread the good word. Thank you for watching.